When the RMS Titanic crossed the Atlantic in 1912, its movement depended on more than just engines and steam. Please subscribe. At the very rear of the ship, beneath the waterline, were three enormous propellers. The final link in the chain that transformed energy into motion. These massive rotating structures were carefully designed to push one of the largest ships of its time through the ocean with power, balance, and efficiency. To understand Titanic's propellers, it helps to first understand their purpose. A propeller works by rotating through water, creating thrust. As the blades turn, they push water backward, and in response, the ship moves forward. It is a simple principle, but applying it to a ship as large as Titanic required careful engineering and precise design. Titanic used a three-propeller arrangement. On either side of the ship were two large outer propellers, each powered by one of the main triple-expansion steam engines. Between them was a central propeller connected to the ship's turbine system. Together, these three propellers worked as a coordinated system, balancing power and movement. The outer propellers were the largest and most powerful. Each had multiple blades designed to interact efficiently with the water. Their size allowed them to move large volumes of water with each rotation, generating the thrust needed to drive the ship forward. Because Titanic was so massive, the propellers had to be strong enough to handle enormous mechanical forces. The central propeller served a slightly different role. Powered by the turbine system, it added extra thrust and improved efficiency. While it was not identical to the outer propellers, it complemented them, creating a more balanced propulsion system overall. The shape of the blades was one of the most important aspects of the design. Engineers had to consider how water would flow around the blades as they rotated. If the shape was incorrect, the propellers could lose efficiency, create excessive vibration, or place unnecessary stress on the machinery. The curved design of the blades helped optimize movement through the water while maintaining stability. Material selection was equally important. The propellers needed to be strong, durable, and resistant to the harsh conditions of the ocean. Large metal castings were used to create the blades, ensuring that they could withstand continuous operation over long distances. Another major challenge was balance. When propellers rotate at high speeds, even small imbalances can create vibration throughout the ship. Engineers carefully designed and aligned the propellers to minimize these effects, helping Titanic maintain smoother movement through the water. The relationship between the propellers and the engines was direct and continuous. Steam powered the engines rotated shafts, and the shafts turned the propellers. Every movement of the ship depended on this connection working smoothly and efficiently. Control was also a key part of the system. The speed of the propellers could be adjusted through changes in engine output, allowing the ship to increase or reduce speed as needed. However, because of the size and momentum involved, these changes were not immediate. Large ships required time to respond, and Titanic was no exception. From an engineering perspective, Titanic's propeller system reflected the advanced thinking of its era. Designers combined traditional steam engine technology with turbine propulsion, creating a hybrid system that improved efficiency and performance. This approach represented a step forward in maritime engineering. Looking back, the propellers of the RMS Titanic are more than just mechanical parts. They symbolize the scale and ambition of the ship itself. Hidden beneath the water, unseen by passengers, they carried the full weight of the vessel's movement across the ocean. They also remind us of how much precision is required in large engineering systems. Every angle, every curve, every rotation mattered. A ship of Titanic's size could only function when all components worked together in balance. More than a century later, Titanic's propellers remain a fascinating example of early 20th century engineering. They represent a time when ships were becoming larger, more powerful, and more technologically advanced than ever before. In the end, the propellers of the RMS Titanic were more than spinning blades beneath the sea. They were the force that pushed the ship forward. The connection between power and motion, the hidden engines of movement beneath the ocean's surface. And with every rotation, they carried Titanic across the Atlantic, driven by engineering, precision, and the ambition of an era.